All right, today we're going to look at what's called unit rate equations. So in our previous lesson, we were talking about if you don't know the equation, how you can use a table and a graph to help you create that equation. So just a couple things that we want to reiterate to help you guys out with this. Okay, so first and foremost, we need to go over some vocabulary words to kind of help us out with this. All right, so let's go ahead and get started. So if I've had a number in front of x, we've been talking about what this is called. In case you forgot, it's called a coefficient. So a coefficient can be in front of the letter, and it can also be underneath it if you're dividing. But these unit rate words, each, every, per, a, and, each, every, per, a, and, each, every, per, a, and yes, I said it over and over to help you guys out, because if you hear those words, that means that that's going to be your number working with your variable, and it's your coefficient. For example, if you run a mile in 9 minutes, for every 9 minutes, you run 1 mile. So if we wanted to see how long it would take you to run 3 miles if you stayed at that constant rate, you would say 9 times 3 miles. So it would take you 27 minutes. And we'll practice those as well. Now the other part, well, this number after the coefficient is called your variable. And the reason why it's called a variable is it varies, it changes. X is not always the same amount every single time. And we've seen that when we've been solving our equations and our two-step equations as well, that x varies. It's not always worth 3 or negative 8 or 12 or anything like that. And the other thing about variables is, yes, we use the letter x a lot, but you don't have to use the letter x. You can use any letter you want. So in this situation, if I said $25 each month, let's say that I'm saving $25 each month, and I want to know how much money I would have after 8 months, well, think about it. What would you do with $25 in 8 months? What operation would you do? Hopefully you said 25 plus 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 25. You're like, I didn't say 25 8 times. I said 25 times my months. And that's exactly what we do. Depending on how many months you go by, is working on how much money you save depends on how many months go by. So we're going to take our coefficient and multiply by those months, and we get our total money. So if I say $25 each month, 25 times n. If I say I'm going to walk 2 miles every day, well, 2 miles times the amount of days that I walk is going to be equal to how many total miles I walk. So these are my expressions right now. I can't do anything else until I know what I'm looking for to solve this. So 65 miles per hour. So 65 miles times the amount of hours. If I say 50 cents a pound, if I go to the grocery store and I'm buying fruit and it's 50 cents a pound, we're going to say 50 cents per pound. And I'll just use the letter P even though the abbreviation for pounds is LBS. We just want to use one variable. So here's what we're going to do. We need to know this background knowledge so that when we're writing our equations, we are more comfortable with where your coefficient goes and what's happening. So let's look at 2 problems together, and then we'll get some practice for you. So if we start with this first problem, it says Mr. Jackson gets 12 hours of vacation for every month he works. So 12 hours for every month he works. Write an equation that represents the relationship between M, the months worked, and V, the hours of vacation. So they're already telling you what your variables are, okay? So when we look at this, we're not using y on x. So this is where we want to help you guys out, and we said y depends on x. But we don't always have y and x. So let's think about it. X is your independent variable that's going to happen no matter what. What is the vacation time going to happen no matter what? Or the month's going to go by? Basically, when Mr. Jackson, whether he's working or not, is his vacation time going to happen or the month's going to go by? And hopefully you said months. When it's dealing with time, that's going to go by. So whether he's working or not, that time is happening. So the vacation depends, the vacation he earns depends on how many months he works. So they didn't really use the letter Y, they used the letter V. So I'm going to say this is like your Y, if this helps you out. And then your months was really like your X right here. Okay? So let's think about it. If you're earning 12 hours every month, well, 12 every month, well, doesn't that mean 12 times the months? Hopefully you said yes, because if he's worked 0 months, well, he's earned 0 amount of vacation. If he's worked 1 month, he's earned 12 hours. If he's worked 2 months, he's done 24. If he works 3 months, he has 36. Okay? So each, every, per, a, and. 12 hours every month. So as soon as you see 12 every month, it's actually telling you that that's your coefficient. 12 every month. So your unit rate is 12. Your rate of change is 12. Your constant of proportionality is 12. But in words, it's actually 12 hours for every 1 month. Because your unit rate is per every 1. A rate is a comparison between 2 unlike things. So hours and month are not like each other. And these are hours of vacation, vacation hours. Okay? And that way, vacation, I spelled that wrong. Vacation, there we go. So a rate is a comparison between 2 things. A unit rate is for every 1 of something. So we are looking for every 1 month. So those all reduce to the same thing. All right, let's keep practicing. Let's do one more. Chris earns money by mowing lawn for his neighbors. He earns $20 per lawn. So right there, I see a number, $20, and I see per lawn. Each, every, per, a, and. $20 per lawn. Well, think about it. If he were to mow 3 lawns, what operation would your brain tell you to do to see how much money he makes? Would you add, subtract, multiply, or divide? Okay. Write an equation to represent the relationship between the number of lawns mowed L and the total dollars earned D. And again, this makes sense because we have 2 different things happening. Blank depends on blank. Well, does your lawns depend on your money earned, or does your money earned depend on the lawns? Hopefully you said the money depends on the lawns. Okay? So when we do that, the money is my dependent, and the lawns earned is my independent. So if you keep writing it this way, that's going to help you out, because sometimes they're not going to give you this, of course. This is just kind of help prompt you. But if this was a multiple choice up here, a trick answer would have been M equals 12V. So if you kind of get in the habit of working this out, it's going to really help you out. So each, every, per, a, and $20 per lawn, they're telling you right there, that's going to be your variable, and the 20 goes in front. So if I take 0 and I substitute that in, 20 times 0 is 0, which makes sense. You can't make any money if you haven't mowed any lawns yet. If he's mowed 1 lawn, well, that's $20. And if he's mowed 2 lawns, well, 20 times 2 is 40. So your unit rate is going to be this number right in front, right here in front of that variable. So your unit rate is 20. Your rate of change is 20. Your constant of proportionality is 20. And what that really represents, if it's y over x, but really we said it was the money per lawn makes $20 for every 1 lawn. Okay, just so you know what these numbers are representing. All right, so again, if you have any questions, make sure you reach out to your teachers. It's just going to take some practice to get better at these so that we know from a verbal description how we can write the equation and how we can fill out the table. But again, use this sentence stem. It helps you out. Blank depends on blank, so your output is going to be your dependent. Your input is going to be your independent variable. That's going to be your variable after the coefficient.